not just by reputation but by assumption. Power, size, and durability were considered settled facts, rarely questioned. But in the late 1970s, that certainty was quietly challenged. Not by advertising, not by politics, but by controlled tests designed to strip away brand loyalty, national pride, and expectation. What followed was not a clean victory or an obvious defeat, but something far more unsettling. Numbers appeared that didn't behave as expected. Results repeated themselves across continents, and instead of ending the argument, the tests ignited one that would drag on for years. This is the story of those trials, where machines were measured, rules were contested, confidence cracked, and the truth became harder to accept than anyone anticipated. The tests that were supposed to end the debate. By the late 1970s and early 1980s, the global heavy machinery industry was under growing pressure to prove its claims with numbers rather than reputation. Japanese manufacturers, most notably Komatsu Limited and Hitachi Construction Machinery, had expanded rapidly outside Asia, challenging long-established American dominance led by Caterpillar, Case, and International Harvester. Dealers, contractors, and government procurement agencies were demanding objective answers. Which machines actually performed better when stripped of marketing and national pride? To address that question, a series of formal comparative trials were organized between 1978 and 1984, conducted at multiple test sites in the United States, Australia, and Southeast Asia. These were not promotional demonstrations. They were structured evaluations overseen by independent engineers, large contractors, and, in some cases, public sector procurement bodies tied to mining and infrastructure projects. The goal was explicit: run Japanese and U.S. machines side by side under identical conditions, and let measurable performance settle the debate once and for all. The tests focused on the backbone of heavy construction: hydraulic excavators and track-type bulldozers. Comparable models were selected based on operating weight, engine output, and intended job class. Komatsu's mid to large excavators were matched against Caterpillar equivalents. Japanese track dozers faced American machines that had dominated earth-moving since the post-war boom. Before testing began, representatives from all manufacturers signed off on protocols covering soil type, duty cycles, operator rotation, fuel measurement, and maintenance inspection intervals. On paper, the process was airtight. The early trials were held at controlled sites in California and Queensland, chosen for their mixed soil composition and stable climate. Tasks were deliberately practical: trenching, bulk excavation, grading to tolerance, continuous pushing, and extended idle-to-load cycling. Performance metrics were clear: cycle time, fuel burn per hour, uptime, heat management, and operator workload. No one expected perfection. What was expected was parity. Instead, from the opening weeks, the results began to unsettle observers. Japanese excavators consistently completed dig and dump cycles faster, not because they moved quicker, but because they required fewer corrections. Operators reported smoother hydraulic response and finer control when positioning buckets. Bulldozers from Japan held grade tolerances with fewer passes, reducing rework. Most concerning for U.S. manufacturers was endurance. Japanese machines logged longer continuous operation with fewer heat-related slowdowns or hydraulic adjustments. Initially, American representatives treated the numbers as statistical noise. Small sample sizes, they argued. Early break-in advantages. Operator unfamiliarity. But as the trials extended into months and similar results emerged from Australian mine site evaluations in 1981, skepticism hardened into alarm. The same trends appeared repeatedly: lower fuel consumption, fewer stoppages, and steadier output from the Japanese equipment. The tests were doing exactly what they were designed to do: remove excuses. And that was the problem. By mid-trial, what had been framed as a technical exercise began to feel like a reputational risk. Caterpillar engineers questioned whether the grading tolerances were unrealistically tight. Case representatives raised concerns about duty cycle realism. Some U.S. observers argued that the tests rewarded precision work rather than the punishing high-load abuse machines faced on North American job sites. Japanese teams responded with documentation showing that every parameter had been approved jointly before testing began. The tension was not confined to the field. Internal correspondence from the period, later referenced in industry publications, revealed growing anxiety within American firms about how the data might be interpreted if released without context. These trials were never meant to embarrass anyone. They were meant to confirm what many already believed. Instead, they were producing answers that no longer aligned with expectations. Despite the friction, test administrators pressed forward. Additional operators were rotated in. Instruments were recalibrated. Runtimes were extended. The belief was that more data would calm the dispute and validate the process. Instead, the performance gap narrowed only marginally, and sometimes widened. By the end of the first major testing phase in 1982, the original objective had quietly collapsed. The trials had not ended the debate. They had intensified it. What was meant to be a neutral benchmark had become a fault line, exposing deep disagreements over what performance even meant. The machines continued to run. The numbers continued to accumulate. But the atmosphere had changed. These tests were no longer about proving superiority. They were about questioning the very conditions under which truth was measured. Confidence before the data arrived. Long before the first engine was started or the first trench was cut, the outcome of the trials felt predetermined, at least from the American side. By the time formal comparative testing began in the late 1970s, U.S. manufacturers had spent decades at the top of the global heavy machinery hierarchy. Caterpillar, in particular, was not merely a company, but an industry benchmark. Its yellow machines dominated construction sites, mines, and infrastructure projects from North America to the Middle East. Confidence was not arrogance, many executives believed. It was the natural result of history. That confidence shaped everything leading into the trials. Internal planning documents from U.S. firms during 1977 to 1979 treated the tests less as a risk and more as a formality. The assumption was that Japanese machines, still viewed by many as efficient but lightweight alternatives, would struggle under prolonged, demanding conditions. American engineers expected superior horsepower, mass, and structural durability to assert themselves once the work became truly punishing. The trials were seen as an opportunity to demonstrate dominance with numbers to back it up. Japanese manufacturers entered under very different assumptions. Komatsu, which had publicly committed to challenging Caterpillar head-on as early as 1972, approached the tests cautiously. Rather than predicting victory, Japanese engineers focused on consistency and compliance. Their preparation centered on ensuring machines were precisely within specification, hydraulics were tuned conservatively, and maintenance protocols were followed to the letter. For them, survival under scrutiny mattered more than spectacle. The imbalance in expectations was visible even at the test sites. During early setup phases in California in 1979, U.S. representatives openly discussed expected outcomes with contractors and observers. Comments about real machines versus efficient machines circulated informally. Japanese teams, by contrast, kept discussions technical and restrained, deferring repeatedly to the written protocols. Confidence, on one side, was cultural. On the other, it was deliberately muted. This disparity extended to how the trials were framed internally. American manufacturers viewed performance as something that would reveal itself naturally under stress. Japanese manufacturers viewed performance as something engineered into repeatability. These were not just different strategies, they were different beliefs about what mattered when machines were pushed beyond brochures and sales claims. When the first machines were staged for testing, that confidence remained unshaken. American excavators and bulldozers arrived heavier, louder, and visually imposing. Operators familiar with U.S. equipment gravitated toward them instinctively. There was a quiet assumption that once work began in earnest, early anomalies would resolve themselves. The data would fall into line. But before any formal results were released, cracks began to form. Not in metal, but in expectations. During initial shakedown runs, Japanese machines demonstrated unusual smoothness. Operators noted reduced fatigue during long cycles. Fuel logs showed lower than expected consumption even before full testing commenced. These observations were dismissed as inconsequential, the kind of marginal differences that disappear under sustained load. Confidence remained intact, but it began to rely more on belief than observation. The real shift came when engineers started reviewing interim logs in late 1980. No official summaries had been issued, yet internal calculations hinted that Japanese machines were meeting or exceeding targets with less variance. This was not failure, but it was not dominance either. For companies accustomed to clear superiority, parity alone was unsettling. Rather than adjusting expectations, many U.S. representatives doubled down on them. Explanations were prepared in advance. If Japanese machines showed early strength, it would be because conditions favored efficiency. If American machines lagged temporarily, it would be because they were built for harsher realities not yet simulated. The data had not arrived, but the narrative already existed. This preemptive framing would soon matter more than anyone anticipated. As formal testing moved toward full operational cycles in 1981, confidence began to harden into defensiveness. Engineers were instructed to document anomalies aggressively. Observers were encouraged to flag procedural concerns. The assumption that American superiority would assert itself later became a kind of insurance policy, one that delayed serious engagement with what the numbers were beginning to suggest. Japanese teams noticed the shift. Requests for clarification increased. Questions that had never been raised during protocol approval were now appearing in daily briefings. From their perspective, the tests had not changed. Only the mood had. Confidence, once casual and assured, was becoming guarded. By the time the first verified performance summaries were prepared, the psychological groundwork had already been laid. The trials had not yet produced conclusions, but they had exposed something equally important. One side had entered expecting confirmation, not challenge, and when confidence arrives before the data rarely lands quietly. Results that didn't match expectations. When the first consolidated performance summaries were circulated in early 1981, the reaction was immediate and uneasy. These were not final reports, nor were they intended for public release. They were internal compilations prepared by test administrators and participating engineers, aggregating weeks of logged data from excavators and bulldozers operating under controlled conditions. Yet, even in this preliminary form, the results carried a weight that was difficult to ignore. Across multiple sites, including the original California test grounds and ongoing evaluations at Queensland mine locations, Japanese machines were meeting or exceeding benchmark targets with a consistency that clashed sharply with expectations. Komatsu hydraulic excavators showed faster average cycle completion, not through speed, but through reduced correction time and smoother hydraulic response. Hitachi machines, tested alongside them in select runs, demonstrated similar stability, reinforcing the trend rather than appearing as outliers. American machines were not failing. That was part of the problem. Caterpillar and Case excavators delivered strong peak output and handled heavy loads without structural issues. Bulldozers pushed hard, held traction, and demonstrated the raw power they were known for. But when the numbers were averaged over extended operation, 8, 10, sometimes 12 continuous hours, the gaps began to emerge. Fuel consumption climbed faster. Heat management required more frequent pauses. Minor adjustments accumulated into measurable downtime. For decades, American dominance had been built on the assumption that endurance favored mass and horsepower. These results suggested something more complicated. By mid-1981, engineers reviewing the data noticed patterns that could not be attributed to chance. Japanese machines showed narrower performance variance between operators. Where American machines fluctuated depending on handling style, Japanese equipment produced remarkably similar outputs regardless of who was in the cab. Operator logs consistently mentioned smoother controls, reduced fatigue, and less physical correction during long shifts. Fuel data became the most contentious category. Logged fuel burn per hour showed Japanese machines consuming noticeably less while maintaining comparable output. In some excavator classes, the difference exceeded 15%, a figure that immediately triggered scrutiny. American representatives questioned sensor accuracy, fuel quality, and measurement methodology. Test administrators responded by recalibrating instruments and repeating measurements. The margins tightened slightly, but the advantage remained. What unsettled observers most was how unremarkable the Japanese performance appeared on the surface. There were no dramatic demonstrations, no aggressive maneuvers, no obvious signs of machines being pushed to their limits. They simply ran, hour after hour, within specification. In contrast, American machines delivered moments of dominance, followed by moments of adjustment. Over time, those moments added up. By late 1981, as results from additional trials in Southeast Asia were folded into the dataset, the trend held. Different soil, different operators, different climates, similar outcomes. The consistency of the pattern became impossible to dismiss as regional bias. The response from U.S. manufacturers was not denial, but reframing. Engineers emphasized that the tests did not simulate real abuse. Executives argued that American machines were designed to survive worst-case scenarios, not captured by controlled trials. Performance, they insisted, could not be reduced to averages. Japanese engineers countered that sustained accuracy and uptime were precisely what modern contractors demanded. Meetings grew tense. Discussions that had once focused on data now centered on interpretation. Were these results revealing genuine performance differences, or simply highlighting the limits of the test framework? The same charts were used to support opposing conclusions, depending on who was presenting them. Internally, concern spread. By early 1982, memos within U.S. firms acknowledged that if these figures were accepted at face value, they would raise uncomfortable questions for buyers and procurement agencies. The issue was no longer about winning or losing a test, it was about credibility. Long-held assumptions were colliding with documented outcomes. Japanese teams, meanwhile, remained restrained. Their focus stayed on compliance, repeatability, and verification. They resisted framing the results as victory, aware that overt confidence could inflame an already volatile situation. Yet privately, there was recognition that the machines were doing exactly what they had been designed to do, and that the data was finally reflecting it. By the time the next phase of testing was scheduled, expectations had inverted. What was once assumed to be inevitable American dominance now required explanation. The results had not matched the narrative that preceded them, and once expectations collapse, every number that follows becomes suspect, not because it is wrong, but because it refuses to fit the story already written when the rules came under fire. Once the results began to contradict expectations, attention shifted rapidly away from machines and toward methodology. The question was no longer whether Japanese excavators and bulldozers were performing well, but whether the rules governing the trials were fundamentally flawed. By 1982, what had begun as a technical evaluation was increasingly treated as a procedural dispute, with the testing framework itself placed under scrutiny. American manufacturers led the challenge. Representatives from Caterpillar, Case, and affiliated dealer networks argued that the trials overemphasized precision and efficiency at the expense of brute force capability. They pointed to grading tolerances measured in millimeters, cycle time averages, and fuel consumption metrics as evidence that the tests favored Japanese design philosophy. According to their interpretation, the rules rewarded finesse rather than the kind of sustained punishment U.S. machines were built to endure. Soil conditions became the first major battleground. At the primary test sites in California and Queensland, U.S. engineers argued that the soil blends, carefully prepared to ensure consistency, did not reflect the unpredictable, abrasive environments common on North American construction and mining sites. They claimed that heavier clay, rock-laden terrain, and extreme slope conditions would tell a very different story. Japanese engineers responded that uniform soil was essential for controlled comparison, and that variability would introduce noise rather than clarity. Next came the issue of duty cycles. American representatives contended that the work patterns, extended, steady operation with scheduled breaks, did not simulate real-world abuse, where machines are often overworked, under-maintained, and operated aggressively. They argued that American equipment was designed with excess capacity precisely to survive such conditions. Japanese teams countered that the trials were never meant to measure abuse tolerance, but operational performance under defined workloads, which had been agreed upon in advance. Grading tolerance emerged as a particularly sensitive topic. Japanese bulldozers consistently required fewer passes to achieve target grades, a result attributed to smoother hydraulic control and finer blade responsiveness. U.S. manufacturers argued that such tight tolerances were unrealistic and irrelevant to most job sites, where speed often matters more than precision. Test administrators pushed back, noting that tolerance thresholds had been established collaboratively and reflected standards increasingly demanded by large infrastructure projects. As the arguments intensified, calls for rule changes multiplied. Some U.S. firms proposed heavier loads, longer push distances, or relaxed tolerance requirements. Others suggested excluding fuel efficiency from overall scoring, arguing that it distorted performance evaluation. Each proposal was met with resistance, not only from Japanese manufacturers but from independent engineers who warned that midstream changes would compromise the integrity of the data. The most controversial demand involved retrospective reinterpretation. American representatives argued that even if the rules had been agreed upon initially, they had proven inadequate in practice and should be reconsidered. Japanese teams viewed this as a fundamental breach of trust. From their perspective, the rules were only being questioned because they were producing unwelcome results. Changing them after the fact, they argued, would undermine the very purpose of objective testing. Test administrators found themselves under increasing pressure. Meeting minutes from 1982 to 1983 reveal prolonged debates over whether limited retests should be authorized under modified conditions. Eventually, some adjustments were approved, additional runs with altered duty cycles and heavier loads, but always alongside the original protocols. The intent was to address criticism without invalidating existing data. The outcome was not the resolution many expected. While modified tests shifted individual metrics, the overall performance trends remained largely intact. Japanese machines continued to demonstrate lower fuel consumption, steadier output, and fewer interruptions. Rather than settling the dispute, the persistence of the results deepened suspicion on all sides. For critics, it suggested hidden bias. For supporters, it confirmed robustness. What became increasingly clear was that the argument was no longer about rules in a technical sense. It was about definitions. What counted as real work? What constituted meaningful performance? And who had the authority to decide? The same framework that once promised clarity had become a mirror, reflecting conflicting priorities and identities. By late 1983, the rules themselves had become inseparable from the controversy. Every metric was contested. Every threshold is debated. The trials continued, but the belief that rules alone could produce consensus had evaporated. When the rules came under fire, they revealed more than procedural weakness. They exposed how deeply expectations shape acceptance and how difficult it is to agree on fairness once confidence has already been shaken. Retests, revisions, and rising suspicion. By 1983, the pressure to revisit the trials had become impossible to ignore. The original testing framework, once defended as neutral and comprehensive, was now viewed by many U.S. manufacturers as insufficient, or worse, misleading. Calls for retesting no longer came quietly through technical channels. They arrived formally, backed by legal teams, senior executives, and, in some cases, major buyers who feared making procurement decisions based on disputed data. Test administrators agreed to a limited series of retests and revisions, but only under strict conditions. The original results would stand. Any new trials would be additive, not corrective. This compromise was meant to preserve credibility while addressing mounting criticism. Instead, it created a new layer of suspicion. The revised tests began in late 1983, primarily at expanded sites in Nevada and Western Australia, where terrain could be made harsher without sacrificing consistency. Duty cycles were adjusted. Bulldozers were assigned longer push distances with heavier loads. Excavators were pushed through extended high-output runs designed to simulate demanding production schedules. Operators were rotated more frequently, and maintenance windows were intentionally compressed. On the surface, these changes appeared to favor American machinery. Yet, as the retests progressed, familiar patterns re-emerged. Caterpillar and Case machines responded well initially, demonstrating impressive power under increased load. But as operating hours accumulated, fuel consumption climbed sharply. Hydraulic temperatures rose faster. Short pauses for adjustment became more frequent. None of this constituted failure, but compared to Japanese equipment, the differences were now unmistakable. Komatsu and Hitachi machines, operating under the same revised conditions, showed marginal performance degradation but maintained tighter consistency. Fuel efficiency gaps narrowed in some runs but did not disappear. Uptime remained higher. Operators continued to report smoother control and reduced fatigue during long shifts. For critics expecting the revisions to reverse outcomes, the results were deeply unsettling. Instead of restoring confidence, the retests intensified doubt. U.S. representatives began questioning not just test conditions but intent. Why, they asked, did revised trials still rely on metrics such as average fuel burn and cycle stability? Why were peak output and overload tolerance not weighted more heavily? Some argued that the revisions had been superficial, adjustments made to appear responsive without addressing core bias. Japanese engineers rejected these claims. They pointed out that the revisions had been proposed by American manufacturers themselves. Load factors, duty cycles, and maintenance constraints had all been altered in response to U.S. objections. If the results remained unfavorable, they argued, the issue could no longer be dismissed as procedural. Behind the scenes, suspicion hardened into mistrust. Emails and meeting notes from 1984 reveal increasing hostility during review sessions. Data validation discussions grew adversarial. Each recalibration was scrutinized. Each anomalous reading was challenged. Even third-party engineers found their neutrality questioned by both sides. What made matters worse was the growing awareness that no retest could fully satisfy all parties. Every adjustment raised new objections. If conditions were too controlled, they were unrealistic. If they were too harsh, they were unscientific. The goalposts appeared to move with every result. At the same time, buyers and contractors observing the process grew impatient. Large mining firms in Australia and infrastructure contractors in Asia were less interested in philosophical debates than in operational reality. They watched machines perform day after day under both original and revised conditions. What they saw on the ground did not always align with the arguments unfolding in boardrooms. Test administrators found themselves trapped between credibility and compromise, halt the process, and risk accusations of suppression, continue, and risk endless revision without resolution. In the end, they chose continuation, publishing results with extensive methodological notes and disclaimers. But by then, the damage was done. The retests had not clarified the truth. They had multiplied interpretations. For U.S. manufacturers, the persistence of Japanese advantages suggested a flawed framework that could never capture real performance. For Japanese firms, the repeated challenges looked like resistance to data that refused to change. Suspicion now surrounded everything: the rules, the revisions, and even the motives behind them. The trials continued on paper, but their original purpose, to provide a decisive answer, had quietly slipped out of reach. What remained was a growing realization that retesting could not resolve a conflict rooted not just in machines, but in belief. And once suspicion takes hold, no amount of data is ever enough. Blame shifts from machines to people. When repeated testing failed to overturn the results, the focus shifted again, this time away from metal, hydraulics, and specifications, and toward the humans involved. By 1984, it was no longer the machines under the microscope. It was the operators, the engineers, and the administrators overseeing the trials. Performance discrepancies that could not be erased through retests were increasingly explained through human variables. Operator skill became the most convenient explanation. U.S. manufacturers argued that many operators involved in the trials had greater familiarity with Japanese hydraulic systems, particularly in regions like Australia and Southeast Asia, where Komatsu and Hitachi machines had already gained a foothold. They claimed that smoother results reflected operator comfort rather than inherent machine superiority. Requests were made to limit operators to those trained exclusively on American equipment, or to segregate results by operator background. Test administrators responded by rotating operators more aggressively. Crews were mixed by nationality, experience level, and brand familiarity. In several cases, veteran Caterpillar operators were assigned Japanese machines, while operators accustomed to Komatsu equipment were placed in American cabs. The expectation was that any operator bias would quickly surface. Instead, the data complicated the narrative. While individual productivity varied, as it always does, the overall trends remained intact. Japanese machines continued to show tighter performance clustering regardless of operator. American machines showed wider variance, with results improving or degrading more sharply depending on handling style. To some engineers, this suggested robustness versus sensitivity. To critics, it raised new suspicions about test design. Fatigue soon entered the argument. Operator logs revealed that crews reported lower physical strain during long shifts in Japanese excavators and dozers. Seats, control responsiveness, and vibration levels were frequently cited. U.S. representatives dismissed these reports as subjective and culturally influenced, arguing that comfort had no place in serious performance evaluation. Japanese engineers countered that fatigue directly affected productivity, error rates, and safety, and therefore could not be ignored. As debates intensified, blame began to drift toward the test administrators themselves. American manufacturers questioned whether oversight teams were truly neutral. Why, they asked, were operator comments being recorded at all? Why were qualitative observations included alongside quantitative metrics? Even though such data had been part of the original protocol, it was now portrayed as a source of bias. Meetings grew increasingly tense. Engineers who had once collaborated openly now spoke defensively. Every data point required justification. Every procedural decision was interpreted through suspicion. In one documented review session in Nevada in 1984, arguments over operator rotation schedules lasted longer than discussions of machine output. Japanese teams, meanwhile, grew frustrated. From their perspective, the human factor was being invoked only because mechanical explanations had failed. They pointed out that if operator influence was decisive, it should have produced inconsistent outcomes. Instead, the machines themselves were reducing variability, a design goal, not an accident. The dispute over people exposed a deeper discomfort. Accepting the results meant accepting that engineering priorities, such as controllability, efficiency, and operator integration, mattered more than some had believed. For manufacturers whose identity was built on power and durability, that was not an easy concession. By late 1984, even third-party observers noted the shift in tone. Conversations, once grounded in engineering language, now revolved around motivation, familiarity, and intent. success, or failure could be attributed to who was in the seat, who was holding the clipboard, or who was interpreting the spreadsheet. Yet, despite all the scrutiny, no evidence of deliberate manipulation ever emerged. Operators followed instructions. Administrators adhered to protocols. The same people, rotated and reassigned, produced the same broad outcomes. The machines behaved consistently, sometimes inconveniently so. For buyers and contractors watching from the sidelines, the argument sounded increasingly detached from reality. On job sites, machines were operated by whoever was available, under imperfect conditions, day after day. A machine that delivered predictable performance regardless of the operator was not a liability. It was an advantage, but that perspective clashed with the internal struggle unfolding within the trials. By shifting blame from machines to people, the controversy entered its most personal phase. Questioning steel and hydraulics was one thing. Questioning competence, fairness, and integrity was another. The trials had begun as a comparison of engineering. They had evolved into a test of trust, and once people, not machines, became the explanation, the path back to consensus narrowed even further. Data, denial, and damage control. By 1985, the trials had produced what most industrial evaluations aim for but rarely achieve: a dense, repeatable body of data, multiple sites, multiple climates, multiple operators. Excavators and bulldozers from Komatsu, Hitachi, Caterpillar, and Case had been measured across hundreds of operating hours. Fuel burn, uptime, cycle consistency, heat management, and operator variance were all documented. Yet, the existence of data did not bring clarity. It brought resistance. Inside U.S. manufacturing headquarters, the response shifted decisively from technical review to risk management. Executives no longer debated whether the numbers were accurate. They debated what those numbers could do if interpreted without control. Internal strategy meetings in Illinois and Wisconsin focused less on engineering corrections and more on messaging. The concern was not failure, but perception, how buyers, dealers, and procurement agencies might read the results. Publicly, American firms emphasized selectivity. Press briefings described the trials as context-specific and non-representative of real-world extremes. Caterpillar spokespeople stressed peak output, structural durability, and overload tolerance, metrics that favored their machines, but were not central to the trial's scoring. Japanese advantages in fuel efficiency and uptime were acknowledged only obliquely, framed as trade-offs rather than strengths. Privately, denial took more deliberate forms. Internal memoranda from 1985 to 1986, later cited in industry trade journals, warned against allowing raw comparative data to circulate without interpretation. Dealers were advised to emphasize customer testimonials over test results. Sales teams were coached to redirect conversations towards service networks, parts availability, and brand familiarity. The data itself was not attacked directly. It was surrounded. Japanese manufacturers faced a different dilemma. Komatsu, aware of the sensitivity surrounding the trials, resisted aggressive promotion. Engineers were instructed to speak only to documented performance and avoid public comparisons. Company statements emphasized compliance with testing protocols rather than victory. The intent was restraint, but it carried its own risk. Silence could be interpreted as ambiguity. As a result, the narrative vacuum filled quickly. Trade publications began reporting selectively, often highlighting controversy rather than conclusions. Headlines focused on disputes over methodology, not on performance patterns. Articles framed the trials as unresolved debates rather than documented evaluations. This framing suited manufacturers seeking time and leverage, but it further muddied public understanding. The most visible form of damage control emerged in procurement contexts. During 1986 infrastructure bids in Southeast Asia and Australia, U.S. manufacturers submitted supplementary performance documentation, emphasizing harsh condition testing conducted independently of the disputed trials. Japanese firms responded with audited trial data and field performance logs. Procurement committees found themselves weighing not just machines, but competing interpretations of reality. Denial also took institutional form. Some American manufacturers lobbied to exclude the trial data from consideration in government-funded projects, arguing that the tests lacked regulatory oversight. Others proposed new standards bodies or alternative benchmarks, effectively resetting the evaluation landscape. These efforts were framed as calls for rigor, but critics viewed them as attempts to dilute inconvenient evidence. Within engineering teams, the mood grew conflicted. Some U.S. engineers privately acknowledged that the data highlighted real design trade-offs. Efficiency, controllability, and system integration had measurable value, but acknowledging that publicly risked internal backlash. The line between professional honesty and corporate loyalty became increasingly difficult to navigate. Japanese engineers observing this response grew wary. From their perspective, the conversation had drifted far from machines altogether. The data had not been disproven, yet it was being marginalized through narrative control. Meetings that once centered on performance graphs now revolved around public interpretation. Engineering had become subordinate to strategy. By late 1986, the trials still technically existed, but their authority had been compromised, not because the data was flawed, but because acceptance required concession. Denial did not mean rejecting the numbers outright. It meant refusing to let them speak unchallenged. For contractors and buyers watching from the outside, the contrast was striking. On job sites, machines either delivered predictable output or they did not. Fuel either lasted or it didn't. Downtime either accumulated or it didn't. The simplicity of operational reality clashed with the complexity of corporate explanation. Data, once generated, could not be erased, but it could be reframed, delayed, and buried under qualification. Damage control did not change what the machines did. It changed how openly that performance could be discussed. By the end of this phase, one truth was clear. The trials had moved beyond engineering debate into reputational defense. And when denial replaces discussion, the argument is no longer about whose machine performed better, but about who controls the story that performance tells. Results that refuse to be accepted. By 1987, the trials had reached a strange and uncomfortable endpoint. The machines had been tested, retested, revised, recalibrated, and scrutinized across years, continents, and operating conditions. The datasets were complete. Independent engineers had signed off on methodologies. Operators had been rotated, rules adjusted, and objections documented. In any conventional technical process, this would have been the moment of closure. Instead, it marked the beginning of quiet refusal. The final consolidated reports, circulated internally among manufacturers, major contractors, and select procurement bodies, showed the same core findings that had emerged years earlier. Japanese excavators and bulldozers, particularly those from Komatsu and Hitachi, demonstrated superior consistency in fuel efficiency, uptime, and control across prolonged operation. American machines from Caterpillar and Case continued to excel in peak power and structural robustness, but those strengths did not overturn the aggregate results. The numbers had stabilized. The conclusions no longer shifted with additional testing. Yet, acceptance never arrived. Rather than dispute the data outright, U.S. manufacturers adopted a strategy of procedural distance. The trials were acknowledged as one data point among many, useful but incomplete. Executives emphasized that no single evaluation could capture the realities of global construction. In effect, the results were not rejected, they were sidelined. Procurement agencies felt the tension immediately. During late 1980s bidding cycles for mining and infrastructure projects in Australia, Indonesia, and the Middle East, committees found themselves caught between documented trial data and entrenched supplier relationships. Some agencies incorporated the results quietly, weighting fuel efficiency and uptime more heavily without explicitly citing the trials. Others avoided referencing them altogether, wary of legal challenges or political pressure. For Japanese manufacturers, the refusal was both frustrating and revealing. Their machines had performed as designed. The tests had validated years of engineering decisions focused on efficiency, control, and operator integration. Yet, public acknowledgement remained muted. Engineers were advised to let field performance speak for itself, avoiding triumphalism that could provoke backlash. Victory, if it could be called that, had to remain understated. Within American firms, reactions diverged. Some engineering teams viewed the trials as a wake-up call, privately acknowledging that system-level efficiency had been undervalued. Others dismissed the entire episode as a misalignment between laboratory-style testing and real work. The absence of formal acceptance allowed both interpretations to coexist, unresolved. What made the results particularly difficult to accept was their ordinariness. There was no dramatic upset, no catastrophic failure that could be isolated or explained away. The Japanese advantage was incremental, cumulative, and persistent. It emerged in averages, in long shifts, in fuel logs and downtime charts. These were precisely the kinds of metrics that mattered operationally, and precisely the kinds that resisted emotional rebuttal. Attempts to reopen the debate continued. Proposals for new standards bodies, alternative benchmarking systems, and manufacturer-led trials circulated into the late 1980s. Each promised a more comprehensive assessment. None directly contradicted the original findings, they simply reframed the conversation. The original trials became one voice among many, their authority diluted through repetition rather than refutation. On job sites, however, the situation was simpler. Contractors made decisions based on cost per hour, reliability, and predictability. Machines that consumed less fuel and required fewer interruptions quietly gained favor, regardless of corporate disputes. Operators noticed which cabs left them less fatigued at the end of a shift. Mechanics noticed which systems needed fewer adjustments. These observations rarely entered official reports, but they influenced choices all the same. By 1989, the trials had effectively ended without ceremony. There was no final announcement, no decisive declaration. The data existed, cited occasionally and selectively, but never fully embraced. The industry moved forward without consensus, carrying unresolved conclusions beneath the surface. The refusal to accept the results did not stem from a lack of evidence. It stemmed from what acceptance implied. Acknowledging the findings meant admitting that long-held assumptions about power, dominance, and design priorities were incomplete. It meant conceding that performance could be measured in quieter ways than tradition allowed. In the end, the results refused to be accepted, not because they were wrong, but because they were inconvenient. They did not align with identity, expectation, or history, and so they lingered, unresolved yet influential, shaping decisions without ever being formally endorsed. The tests had answered the technical questions they were designed to ask. What they could not resolve was whether the industry was prepared to listen.